Okay, guys, in this video, we are going to review dot product and cross product and their applications. It is very important in a question like this to take your time to write down the question and all the points, and everything should be documented and very carefully written down, because if you just lose one negative somewhere, you are going to get a lot of stuff wrong. So let's see if we can write down. We're going to need, for the rest of this question, we're going to need vector AB. And the way we find it is we just subtract the coordinates. So that will become 2 minus 1, negative 6 subtract negative 1, and 0 subtract 7. So vector AB is going to be 1, negative 6 plus 1, that's negative 5, and negative 7. Okay, so we're going to write that down. Then we also will need AC. And this is where we subtract the coordinates of A from C. And again, see how I'm writing it all out, even though I don't have to, but this makes it less likely that you are going to mess it up, right? And miss a minus. So this will be negative 2. This is negative 7 plus 1, negative 6, negative 7. Now, I'm also going to need AD for later on. So while I'm at it, I'm going to do that right now. So that will be negative 5 minus 1, 1 minus minus 1, and then 8 minus 7. So that becomes negative 7. 1 plus 1 is a 2, and that's a 1. Okay, so let's fill out some of the stuff we just got. So for AB is 1, negative 5, negative 7. For AC, I've got negative 2, negative 6, negative 7. Now, if I want the magnitude of these vectors, this is where you just want to add up squares of each coordinate, but do not include the negatives, because when you include the negatives, there's always a possibility of messing this up. So this is going to be square root of 75. Now, let me do the other one, especially if you don't put the parentheses in order, and you are in trouble. Okay, so this will be square root of 89. Now, the question is asking next is to find the dot product. So when I want to find the dot product, this is where I just multiply the coordinates or the components and add them up. So dot product is not a vector, it's a number. AB and AC. 1 multiplied by negative 2 plus negative 5 times negative 6 plus negative 7 times negative 7. So that's going to be 77 for the dot product. Now, if I want to find the angle between these two vectors, AB and AC, the way I do it is I'm going to go to function and make sure that it's in degrees, and then click on inverse cosine. On the top, you want your dot product. On the bottom, you want the magnitudes multiplied. So I've got 75, and then I've got another square root 89. And that will give me my angle that goes in here, 19.5 degrees. Now, to find out if vectors AC and AD are orthogonal, what you're supposed to do is find the dot product. So please make sure that on the test you are showing me detailed work. So if I ask the dot product, that you are going to write it out so that I can see what you are putting on a calculator. And so that's what I'm writing on paper right now, and also indicating that that's not a vector. Okay, so let's see if we can type that up here. So that would be negative 2 times negative 6 plus. Okay, I got negative 7. And if the vectors are orthogonal, then the dot product would be 0. And obviously that did not happen here, so that's going to be a no. Now, the next question deals with the area of a triangle ABC. In order to do that, we need to find the cross product of vectors AB and AC. Okay, so I will put IJK as the first row. Then AB vector, which I have as 1, negative 5, negative 7. So this is part C. That goes in the second row, and then AC vector, which is negative 2, negative 6, negative 7, goes as the last row. Okay, for the ith component, you want to cross out the first column and the first row. And then you will get a determinant -5 times -7, which is 35. Subtract -6 times -7, which is 42. Okay, so that's my ith component. The jth component, you're going to cross out the second column and again the first row, and that becomes -7 subtract -2 times -7 is 14. So subtract 14 and then plus k. So for kth component, you want to cross out the last column and the first row, and we are multiplying 1 times -6 subtract -2 times -5 is 10. Okay, so it looks like for, the cross product is going to be -7 for the I. Now, -7 minus 14 is -21. So that'll be +21. So please remember that the jth component is negative. And then we have -16. Now, how do I know my answer is true? I always recommend, even if I'm not asking you directly to do that, verify your answer. So look at the second row of the cross product and find the dot product of it with your answer. So 1 times -7 plus -5 times 21 plus -7 times -16. That should be 0. Okay, if that's 0, that means that's good, but then you also have to check the second vector, which is -2, and then so I'm just finding the dot product and I am hoping that that's 0. That is 0. So that means that I got the cross product correctly. I don't even have to worry about checking it because I know this is right. Okay, the next question says find the magnitude of it. Well, that's easy. So we're just gonna square each component, disregard the signs, and that's gonna be 746. So the magnitude is gonna be square root of that. Now, this is according to a formula, that's actually area of a parallelogram with AB and AC as adjacent sides. But because this is asking area of the triangle, triangle is half of the parallelogram. So you're just gonna take the square root and divide it by 2. That would be the answer there. Okay, so in terms of the parallelepiped, that's gonna be part D. Now, how do I find the scalar triple product? There are a couple of ways you can do it. And in terms of order of how you do it, doesn't matter which of there should be two vectors that are crossed and they should be dotted, whatever the answer is, dotted with the third vector. The order doesn't matter because when you find in the volume of a parallelepiped, you will have to take absolute values. So switching order may only result in a change of sign, but when you take absolute value, that's not going to be the case. So because I already found the cross product right here, I found AB crossed with AC, I got that. Now I can just find the dot product of that with AD. So this is my cross product, -721, -16, and I am going to just dot it with AD, which was -6 to 1. And that becomes my scalar triple product. Let me just type that here. Okay, I got a positive number that is 68. However, if the answer was negative, I would switch sign. So if the answer for the volume should always be a positive number. There's no way that that's negative, so always take absolute value. Okay, I think the last question here deals with the equation of a plane through points A, B, and C. How do I do that? Well, in order to write down equation of a plane, I need two things. I need normal to the plane, and I need a point. So normal to the plane would be a vector, and there will be some point P with coordinates, let's say x0, y0, z0. So the equation here, if normal vector has components a, b, c, then it's going to be a times x minus x0 plus b, y minus y0 plus c, z minus z0 equals 0. So this is something that you will see on the formula sheet. You know that. Now, what is the vector that's normal to the plane? Now, what the theory tells us is that if you have two vectors on the plane, so you've got AB and you've got AC, the vector that's a cross product will always be orthogonal to each of the vectors, which we, by the way, verified when we were finding the cross product. We verified that it was orthogonal with each of the individual vectors. So we already know normal to the plane. That's the -7, 21, -16. That's the cross product. So we already know that. Okay, so we just need to have a point, but because this plane goes through A, B, and C, all we need is just one point. So going way back up, I think I'm going to take point C because it has 1, 0, so that's just going to be easier for me. The other coordinates are not 0, but the third is 0, so it's a little bit easier, but no matter which point you take, you should get the same answer. So I get -7 and then x plus 1, then plus 21, and then I multiply that by y plus 7. So remember, we subtract, right? So subtracting -7 is add 7. And then plus, okay, so then the negative, actually this is going to be minus because it's -16. So -16, z minus 0. And then the whole thing has to be 0. Now, you do have to simplify. So if you don't simplify, you're not going to get full credit. So you have to distribute everything. This should be -7x minus 7 plus 21y plus, well, what is 21 times 7? So that's 147 minus 16z equals 0. The final answer will be -7x plus 21y minus 16z, and then 147 subtract 7, that's just 140. So it looks to me like that's the equation. But how do I know this is true? So here's what I recommend you do on the test, which of course I will be asking you this question for sure. So I will be typing this equation in a function f of x, y, z. Then I'm going to go way back up to all the points that are supposed to belong to this plane. And I'm going to plug them into the equation. And the answer should be 0. And so if it's not 0, I messed up. So I just plugged A, that works. Let's plug B, that also works. Let's plug C, that is also works. So I know that this equation is correct.